All right, this video is going to walk you through the basics of sequences and building your way up from level 1 all the way up to level 3. The first thing you need to understand is that when you see a sequence, that the very first number is the first term. It is not the zero term. So as you try to build equations for these sequences, it's important that you always work backwards and get the zero term as well. So what you're going to notice here first is our sequence is going 1, 4, 7. Now it's pretty easy for a lot of you to see what this sequence is doing. But if you ever aren't sure what the sequence is doing, if you just take next minus previous, like 7 minus 4, you'll get the answer 3. But test out two places, just like 4 minus 1 also gives you 3. So therefore I've verified in two places that if I do next minus previous, the answer is 3. So in other words, then this thing keeps adding 3 as you go forward. As you want to go backwards to get the zero term is found by you subtracting 3. So if you subtract 3, the answer is going to be negative 2. So now you're ready to start building the table. Hopefully you already did this. You got negative 2, 1, 4, 7, and then you got to start adding 3 some more times to get 10, 13, 16. Now the next catch is, when we graph sequences, they are what we call discrete graphs. There is no information between the first term and the second term of the sequence. There's no such thing with things that you count like this, at least, that you would count by a 1.25 term of a sequence. It's either there as the first term or there as the second. There's nothing in between. So we are going to create a discrete graph starting with only the first term. So don't put any dots on this y-axis, such as the negative 2 that you're seeing right here. Our dot needs to be at 1. So we go to 1, 1, put a dot. We go to 2, 4, put a dot. So 2, 1, 2, 3, 4. And then we got to put a dot at 7. So there's 4, 5, 6, 7, 6, 7. And then we got to go to number 410. Go to 410. So you got 3 more. And you'll notice that the 13 does not fit in the paper, and so on. You've now successfully created the graph. Now what we want you to do is, again, state what kind of graph we have. This is a discrete graph because there is no information between those dots. It's just a sequence of terms and their values, and that's it. The rule is started and stated as T of n equals. Now when you build a sequence equation, you always typically want to start with what you start with. The starting term here is this zero term. The zero term here being negative 2. So you'll say negative 2, and then what are you doing to the 2? You're adding 3. So I add 3. Now when you add things over and over, it's going to be times n. That's how that works. So that's the equation you're going to do for this first one. Now as you attempted the second sequence that you see here, it goes 7.5, 11.25. These decimals start growing to be longer and longer. That's kind of a tip-off that something's most likely going to be multiplying. Now if you go to your calculator and take 11.25 divided by next divided by previous, I just did that ahead of time here, and I tested out two places, and you'll notice that in both cases I got the answer of 1.5. So that means if I take this divided by this and also this divided by this and I get 1.5 for both answers, I know it's multiplying by 1.5. 1.5 going forward. Again, if you want to find the equation, you're going to need to find the zero term. So the zero term you're going to find by going 7.5 and dividing that by 1.5 like this, and I get the answer 5. So that means 5 is my zero term. Then from there, what you're going to do is start to build your equation, but remember, or build your graph. But remember, you don't graph this starting value. You start with the very first term at 7.5, so approximate what that is. 1, 2, 3, 4, 5, 6, 7.5. And you're only going to fit 2 dots on here, unfortunately. So then there's, that's 7.5, and we got 8, 9, 10, 11.25. So you can really only fit the first 2 terms of the sequence on here. I wish the graph paper was a little bit better than that, but that's what it looks like right here. So that's all I can fit. Now, for the sake of this graph, we have to also recognize the rule. And the rule is then T of n equals, you work your way back to the 5, so it starts at 5. And then what do you do to that 5? Now, notice that you're multiplying by 1.5, so it's times 1.5 to the power of n. Notice I did power of n when I multiply, and I do times n when I add. Notice the difference between both of those skills of writing those kinds of equations. And again, this graph is made out of dots, so it's just a discrete graph. All right, moving forward, as you try to look at level 2, or pause the video now if you want to try, but I think you should just keep on going here now. Here's what we got. Another sequence. You'll notice that this sequence right here keeps adding 4 as it goes down the table. But when you're writing these equations, we want to know the zero term, so you have to go up the table instead. So if you notice that something is adding, you're going to go and do the opposite of that, which is to subtract. So you subtract 4. But you're not going to just subtract 4 one time, you're going to subtract 4 10 times. And if you simply do subtract 4 times 10, that's a total subtraction of 40. You're going to take 2 and subtract 40 from that and get negative 38. Hopefully you see how that works. Now the next thing is, you're going to want to then write the equation. The simplified equation looks like this. You say t of n equals, we now have figured out what it starts at, which is negative 38, and then you're going to add 4 n number of times. Now what we're learning today is that it was a little bit of work to get back to the zero term. You don't have to go back to the zero term. You can do what's called writing an adjusted equation. The adjusted equations can say, all right, let's not start it at the zero term, let's start it at the 10th term. Let's start right here at the 2, okay? So that 2, I can say then t of n equals, started at 2, how are you going to get to the next term? Well, you're still going to add 4, but instead of saying 4n, we have to say how many moves back to 0 is it? Well, it's 10 moves back. So then you're going to say n minus 10, and that's it. This is the equation that would make that sequence. Now, the next thing on a test or a quiz, when we ask you, or even the homework today, when you're asked for these adjusted equations and you're not 100% confident you have the right equation, you can always check your answers. I'm going to put that equation in here first into my calculator as negative 38 plus 4x, or 4n essentially, but I'm going to write it like this first. I'm going to take what I think my equation is next, which is 2 plus 4, and then parentheses x minus 10. If these are the exact same equations, values that make this sequence, I can verify that with the table. So if I press second graph, now look at the table. It goes negative 38, as I expected. And if I scroll down, the 10th term, as you can see, also is 2. Hopefully you see that as well. And then I also got the 6, the 10, and so on. So this table is verified, A, as both the simplified version and the adjusted version. They both create the exact same sequence. So use your calculator in the future on a test to make sure before you hit submit on the question that you know it's making the right table that you're supposed to be creating. All right, now the next one. What do you do instead? Now if you'll notice here, we multiplied by 10, or when we subtracted 4 10 times, we subtracted 4 and then times 10. We used times with repeated multiplication or repeated addition, but we're going to use powers to show repeated multiplications. Watch how this next one works. As you look at this next one right here, this 12 is being multiplied by what? Well, it's being multiplied by 3. You can see it goes times 3, times 3. And if you didn't see that, just go next divided by previous, or next divided by previous, and you'll get 3 for your answer also. So in other words, then, if you're going to write the simplified equation of this one, you have to work your way backwards. We're going to have to do, instead of going times 3 going down the table, we're going to divide by 3 going up the table. Divide by 3. Now, like I said, with repeated multiplication and in this case division, we're going to use powers to figure this out. So you're not only going to divide by 3 to this 12, but you're going to divide by 3 to the power of moves back. That's to the power of 8, like this. So take your calculator and put in 12 divided by 3 to the 8. Let me do that right now on my calculator here too. 12 divided by 3 to the power. Now the exponent button is right here. It's right below your clear key, so press that button, and then power of 8. And I get this weird decimal. So that's not going to be very easy to write. So if I press math, enter, enter, that's the fraction I'm talking about. 4 over 2187. So 4 over 2187. That's your zero term. Now you're ready to write the simplified version as well. So I'm going to say t of n equals, and my simplified version will be 4 over 2187, and then times the multiplier, which is 3, and then to the power of n. That's it. Hopefully you can figure out how to go backwards when dividing multiple times. You divide by the number of times you have to divide as the power of the number you're going to divide by. In this case, next, we're going to look at how could I make this even easier. Well, let's not start at the zero term and make this crazy decimal fraction here. Let's figure out this one right here. Let's just start at 12 instead. We're going to start at the 12 and say t of n equals, start this equation at 12 and take that times 3, but it's not the zero term. This term, 12, is actually the 8th term, so it'll be to the power of n minus 8. That's all there is to this. Now lastly, if you were to check your answers again in that table, you'll notice that the tables will match. I have the example right here to go with that one. Now we're ready to move on to the last level, which is level 3, which is where you're going to find information missing at the beginning and in between 2 points. We're going to also assume that this is arithmetic, which means it's adding from one term to the next. If you're ever trying to figure out when there's a gap involved, the form that we were using before here, this one right here, has to be changed just a little bit. You're still going to say next minus previous. Let me write it out here. So you got the adding amount is found by doing next minus previous. And it's also important on your calculator that you do parentheses around those two numbers. And then you're going to also divide by the gap. We're trying to find the rate at which it's changing, and that is going to be next minus previous divided by the gap. The gap in this case right here is the distance between those two coordinates. In this case, the gap is 4, okay? Then we also recognize that this is your next and that's your previous, so if you're going to fill this in, it would look like this. You'd have to go 40 minus 20, 40 minus 20, and if you type it in your calculator like this and then divide by the gap being 4, the answer will come out to be, well, 20 divided by 4, that's 5. I just figured out what it's adding by. It's adding by 5. That means going down the table, you're adding 5. Going backwards, you're going to subtract 5 15 times. And if you subtract 5 15 times, that's a total of 75. So if you subtract 75 off of 20, you're going to be at negative 55. So negative 55 would go right here. Now you know the starting value. You also know what it's going by right here. And then you can now write the equation. So the equation of this simplified version, when you actually use the starting value, is going to be T of n equals negative 55, which you start at, the 0 term, and you're going to add 5 n number of times. And then the next thing is, if it's adjusted, let's just pick a spot. Let's do the 15th term, where you say the 15th term is 20. Let's start at 20. We're going to start right there at 20. So T of n equals, start at 20, and then you're going to add 5, but you're not doing 20 at the 0 term, you're doing 20 at the 15th term, so you'll say n minus 15. And that's it. So really all you're trying to do today is learn how to write equations in multiple ways, either by going back and finding the starting value, or using the starting point somewhere else in the sequence and then adjusting it with n minus the number of moves back to 0 that it would be. Hope this video helps, and good luck on your assignment as you try to do adjusted equations.